So before we start to look for absolute maxes and absolute mins, we're going to first practice finding critical points. And critical points, remember, are when the derivative is equal to 0 or when the derivative does not exist. So we're on a search for when those points happen. And in either case, we're going to have to figure out what the derivative is. So that's going to be my first step. And this is just the straight up power rule. And now I'm going to, before I can analyze anything, I'm going to factor. So I'm going to take out a 4 and an x, and that leaves me with an x squared plus a 3x plus a 1. And what that allows me to do is to figure out where is the derivative not exist. Well, this is a cubic actually, so it exists anywhere, but where is it equal to 0? So it's equal to 0 when x equals 0, and the other one is when x squared plus 3x plus 1 equals 0. It would have been nice if that had been able to factor, but it doesn't factor, so I'm going to figure out where it's 0 by using the quadratic formula. So here we go with the quadratic formula. And a is 1, b is 3, c is 1, so it's x equals negative 3 plus or minus 9 minus 4 times 1 times 1 over 2 times 1. And simplifying, I get x equals negative 3 plus or minus root 5 over 2. So I have three critical points, one when x equals 0 and the other two when x is this kind of ugly looking number from the quadratic formula. Now if I ask same thing, critical points, I'm looking for where is the derivative equal to 0 or does not exist. And that means I'm going to take the derivative, and this one's an easy derivative to take. But before I analyze it, I'm going to write it as a fraction. In other words, I'm going to put the x in the denominator. And now I'm going to ask, where is the derivative equal to 0? Well, it's only equal to 0 when the numerator is 0, and that is not possible. So there is no critical point of that type. But where is the derivative not exist? When the denominator is 0, because we can't divide by 0. So x to the 1/3 equals 0 is going to give me a derivative that doesn't exist. Divide both sides by 3. And now I'm going to cube both sides to get rid of that exponent. So x equals 0. So when x equals 0, I get a denominator that doesn't exist. A denominator that is 0, so the derivative doesn't exist, which means we've got a critical point at x equals 0. The y value at that point would be, plugging it back into my f function there, it would be 0 to the 2/3, which is 0. So the critical point is actually 0, 0. Now next one, this one has got a bit of a different flavor because it's got some trig in it, and again I need to take the derivative. So the derivative of theta is 1, the derivative of cosine is cosine, and I want to figure out where does the derivative not exist and where is it equal to 0. Well, these two pieces exist everywhere. It's continuous, so there is no critical point of that type, but there is a critical point of this variety when it's equal to 0. So I'm going to move the plus 1 over, and then I'm going to use the graph of the cosine function to help me answer when is it equal to negative 1. So here's my regular cosine graph, and when is it equal to negative 1? At pi. So theta equals pi. But remember, cosine is continuous, so that means that the next one would happen at 3 pi and the next one would happen at 5 pi. So it's odd multiples of pi, where n is an element of the integers. This is a way of saying odd numbers of pi. You could have actually said pi plus multiples of 2 pi. That would be another way to have written that, and you can tell that if you multiply this out you get this.